Good morning, everyone. Welcome back. I hope you had a wonderful winter break. We're going to kind of ease our way back into quadratics by kind of doing some problem solving. And so, first off, remember I'm saying quadratics, and so that should tell you we're going to have a parabola. That'll also tell you there's going to be an x times x somewhere or an x squared, depending on how you think about this problem. So let's discuss terminology, and then let's get to a problem-solving process. So I'm giving you the first three figures. So here's figure 1, figure 2, figure 3. What we're going to be concerned with is the number of squares. 3 squares, 7 squares, 13 squares. All right, let's imagine this pattern were to continue. So I'm just going to go to figure 4, and I'm going to go to figure 5. So notice how each time there's always one extra square on top. So I know for figure 4 there's going to be one extra square on top. Then if I think about this pattern, notice how below that one square is a 1 by 2, a 2 by 3, a 3 by 4, and I'm betting that figure 4 then is going to be a 4 by 5. So definitely not proportional, but we'll call it an abstract representation. All right, so now if we count that out, this is a 4 by 5, so that's got to be 20 squares plus 1 on top, so that's got to be 21 squares. And figure 5, once again, there should be 1 on top. And then 1 by 2, 2 by 3, 3 by 4, 4 by 5, then this one's probably going to be a 5 by 6. 1, 2, 3, 4, 5, 6. All right, and so now if it's a 5 by 6, that's going to be 30 plus 1 extra. That'll be 31 squares. All right, so now we've talked about, here are our initial 3. Keep the pattern going. Here's 4 and 5. All right, so now the question is, how do I write an equation? So I think there's a couple ways to think about this. And we'll see which ones you like. So method 1, actually I'll just say equation 1. I just want to emphasize that there are multiple ways to approach this that are actually totally the same. So the first way I'm going to think about it is, first, since I want to write an equation, I'm going to say what my variables are. So I'm going to say y is number of squares, and x is the figure number. All right. So as I'm writing the equation here, notice how all of these shapes have one extra square on top. So I'm betting in my equation that there's going to be a plus 1. I'm going to say, in my mind, there's that extra 1 left over every time. The next piece is, I'm going to think about the remaining. So notice how it's a rectangle below that 1 extra square. So notice how it's a 1 by 2 rectangle, a 2 by 3 square rectangle, a 3 by 4, 4 by 5, and 5 by 6. So figure 1 is a 1 by 2, figure 2 is a 2 by 3, figure 3 is a 3 by 4. So notice how, if I take the figure number, one of the sides of the rectangle is that figure number, and the other side is just one more than that. So 1 to 2, 2 to 3, 3 to 4. So in other words, I'm just doing whatever the figure number is times one more than the figure number with the one square left over. So let's do a quick test. Let's test figure 3. So based on my equation, that would mean I have 3 times 3 plus 1, which would be 3 times 4 plus 1, and that would all simplify to 13. And if you notice, figure 3 has 13 squares. That makes us believe we're probably right, but remember, it's a safe bet to always test another figure. So let's test 4. And if we simplify that, that'll be 21 squares. Which figure 4 has 21 squares? We're good to go. So this equation is perfect. And if we head to a graph, wrong screen. If we head to a graph, all I did was put the figure number with the number of squares. So now I can see all those points graphed. You'll see that there's a curve. And so that further backs up that we're going to have a parabola. And now I'm just going to type in that equation. X times x plus 1 plus 1. And sure enough, that equation goes through all the points, and that's just verifying that this is correct. All right, so with that, let's think about an alternative technique. All right. Our alternative is a little bit strange, but some of you might feel a little bit better about this. So starting, I'm going to assume the same thing. I'm going to say there's always that one extra square on top. All right, now I'm going to color code a little bit. I'm going to look for, first, a colored pencil. All right, so what I'm going to say is notice how there's a 1 by 1 square. Notice how there's a 2 by 2 square. And then a 3 by 3, a 4 by 4, and a 5 by 5. And just to acknowledge, we've already taken care of this extra one on top. All right. So once again, this is a 1 by 1, 2 by 2, 3 by 3, 4 by 4, 5 by 5. So in other words, that is just a square that is x times x. I'm going to write an alternative. If you want to write that nicer, that's really x squared, and we still have a plus 1. So this is just a nicer case. But notice how we still haven't taken care of this extra, I guess, line. So maybe you see it. Notice how there is 1 left over in the first figure. There is 2 left over, 3 left over, 4 left over, and 5 left over. In other words, the amount left over is the same as the figure number. So 1, 1, 2, 2, 3, 3, 4, 4, and so on. And so to finish off my equation, there's just x left over. So there's a square, that's the figure number. So once again, a 5 by 5, for example. There was 5 left over, for example. And then there was the 1 on top. So once again, we can test. Let's test figure 2. So that would be 2 squared plus 2 plus 1, which would be 4 plus 2 plus 1, which would be 7. And sure enough, figure 2 has 7 squares. And let's do one more quick test. Let's try figure 5. So that would be 5 squared plus 5 plus 1, which would be 25 plus 5 plus 1, which is 31. And sure enough, figure 5 has 31 squares. And so this equation also works. And if we head to here, let's type in y equals x squared plus x plus 1. Sure enough, it's the exact same parabola. It's just in a different format. So if you notice, if you did x times x, x times 1, you would end up converting to this format. So they're exactly the same equation. They just look a little bit different. They're just thought of visually differently. So what I want to emphasize one more time is the patterns you see today, there's multiple ways to break them down. Here we saw a rectangle with 1 extra. Here we saw a square with an extra line of pieces and then the 1 extra on top, but they both represent the same thing. So you'll have 3 patterns to take a look at today. Make sure you read the directions carefully. And as always, if you have questions, please email me and I'll get back to you as soon as I can. All right, good luck.